Today we're going to look at the chi-square test for independence or homogeneity. In general, we have the null hypothesis as the two factors are independent. And for the alternative hypothesis, we have the two factors are dependent. The null hypothesis and the alternative hypothesis are always complements of each other. And for our null and alternative hypothesis, it's actually easier to put those into sentences rather than symbols. We have two conditions. The first one is all of the expected counts have to be greater than 1. 2, no more than 20% of the expected counts are less than 5. If all of these conditions are met, we can start the problem. Our test statistic is chi-squared. Chi-squared is equal to the summation of the observed minus the expected counts, quantity squared, over the expected counts. Here the degrees of freedom is equal to the row count minus 1 multiplied by the column count minus 1. Again, if you want to do this by hand, you'll have to calculate it using rows and columns. The expected count is calculated by row total times column total divided by the grand total. Today I will be using statcrunch, and the computer will do all of the calculations for the expected counts for us. When I do problems with chi-square of independence, I'm looking for these keywords: related, relationship, dependent, and independent. If I see any of these 4 words in a problem, I know this is a chi-square test for independence. Example 1. In a study of 1,000 randomly selected deaths of men aged 45 to 64, the cause of death along with the victim's smoking habits are listed. Is smoking independent of the cause of death? I see the keyword independent, so we know this is a chi-square test for independence. We want to do the test at alpha equals 0.05 level of significance. Let's look at step 1. We're going to state the null hypothesis and the alternative hypothesis. Remember, the generic null hypothesis is the two factors are independent. So I'm going to look at what the two factors are. I'm looking for their smoking status and their cause of death. So those are my two factors. So for the null hypothesis, I'm going to write smoking and cause of death are independent. And that's it for the null hypothesis. Smoking and cause of death are my two factors, and for the null hypothesis, we always put the word independent. For the alternative hypothesis, it's the complement of the null hypothesis. I'm going to write smoking and cause of death are dependent. And that's it for our null and alternative hypothesis. Step 2, we'll state alpha. Alpha is given as 0.05. Step 3 and 4, we will go to statcrunch for those values. We need to enter the table in statcrunch to do the problem. I need to type in the column for cancer, heart disease, and other. I do not need to type in the total column or the total row on the bottom. The computer will do that calculation for us. We also need to include the first column, and I'm going to label that as the status column for smoker or non-smoker. Let's try the problem on statcrunch now. We'll go to stats, tables, contingency with summary. I want to highlight the columns, and in this case I want to highlight cancer, heart disease, and other. These are our columns. And for the rows, our rows is under status, and the status here contains smoker or non-smoker. So we'll go down and make sure we click expected counts, and we'll press compute, and here is our table. We have our chi-squared statistic on the bottom, 8.349, and our p-value is 0.0154. The numbers in the parentheses here are the expected counts. So if the null hypothesis is true, we would expect these amount of deaths. Our chi statistic is 8.349, and our p-value is equal to 0.015. In step 5, I'm going to ask the question, is the p-value less than alpha? And in this case, the p-value is less than alpha. In step 5, I'm going to ask, is the p-value less than alpha? Is 0.015 less than 0.05? And it is. The p-value is less than alpha. We do reject the null hypothesis. There is enough evidence to conclude, and remember our conclusion is always in terms of HA, so I'll copy HA here. There is enough evidence to conclude that smoking and cause of death are dependent. Remember, your conclusion is always in terms of HA. We do reject the null hypothesis. There is enough evidence to conclude that smoking and cause of death are dependent. Example 2. In a poll, 883 males and 893 females were asked, if you could have only one of the following, which would you pick? Money, health, or love? Their responses are presented in the table below. Using statcrunch, test the claim that gender and response are independent at the alpha equals 0.05 level of significance. Using statcrunch, based on Fox News poll conducted in January 1999. Now I know this is chi-square for independence test because it mentions the phrase independence, and the two factors are gender and response. So that's going to allow me to state my null and alternative hypothesis. Step 1 will state the null and alternative hypothesis. I have here that gender and response are independent. That's our null hypothesis. The null hypothesis always has the word independent in it. Gender and response are independent, which means they're not related. And for the alternative hypothesis, gender and response are dependent. The alternative hypothesis says that males pick certain categories more than females, and females pick certain categories more than males. Step 2 will state alpha. Alpha is 0.05. Step 3 and 4 will go to statcrunch to do the problem. Let's try the problem on statcrunch. I have gender as men or women, and for money we have 82 and 46. For health we have 446 and 574, and for love we have 355 and 273. To do this on statcrunch, go to Stat, Tables, Contingency with Summary. we're going to highlight the columns, and I want the columns to be money, health, and love. For the row labels, the rows will be under the category gender. And I want to also include expected counts for this. And we'll press compute. And here is our contingency table with our results. The chi-squared statistic is 36.8396. And our p-value is less than 0.0001. From StatCrunch, we have the chi-squared statistic is 36.84, and our p-value is less than 0.0001. In step 5, I'm going to ask the question, is the p-value less than alpha? Is 0.001 less than alpha, which was 0.05? Yes, it is. So we do reject the null hypothesis. There is enough evidence to conclude that gender and response are dependent. We do reject the null hypothesis. There is enough evidence to conclude that gender and response are dependent.